Great. See that people are still coming in. All right. Let's get started. Welcome everyone. Today we are very excited to host Mert. Mert is an assistant professor in the Applied Econ Group at Sloan and a research fellow at the NBER. Mert's research is in empirical I/O with a focus on firm productivity, use of digital technologies by firms, antitrust issues, and productivity effects of generative AI. Given how fast AI is advancing, his work is exactly what we need to make sense of all of this. Today he's going to talk about his recent paper on the market structure and pricing of LLMs. Mert, thank you so much for taking the time to be here. The floor is yours.
Okay. Yeah, thank you so much for having me. So I'm excited to present this paper to this audience. So this is a pretty descriptive paper. I'll have a bunch of figures just to describe what is the current state of industry and how this industry is evolving. So our motivation is that AI markets have emerged like very rapidly. So just like a couple of years ago, even like we didn't have LLMs, and all of a sudden LLMs appeared as a new technology, and now we have many firms like model creators, providers entering into this space, providing this service in this market. And despite the importance of this market, there are many open questions that we don't know the answer to. For example, we don't know how much vertical and horizontal differentiation between different models. We don't know actually how prices change over time. So there is some anecdotal like numbers, evidence, but there is no systematic evidence. There is very little information about multi-homing. So for example, do firms switch between different models and so on. So in this paper, our goal is to really provide the first set of answers to these questions using data from two of the largest API marketplace. So we are going to use firms LLM usage from OpenRouter and Microsoft Azure, and we'll document 6 facts about the structure and the dynamics of this market. And these 6 facts cover supply, pricing, market dynamics, differentiation, substitution, and multi-homing. On the supply side, we are going to look at the number of models and creators entering this industry. We'll look at the evolution of pricings on the pricing side. Market dynamics is going to be about how often we observe entry and exit of different models and creators. Differentiation will be about whether there is a single model that dominates across different categories. And substitution will be about what happens when there is a new model enters. Do people substitute between the models or there is market expansion? And finally, we are going to look at some multi-homing to see whether firms use multiple models at a given time. So I'm just going to have a few figures for each of these to support the fact that we document. Our focus is LLM markets, LLM inference sold via API. So this is different than like ChatGPT, which is a business to consumer B2C product, or this is also different than coding applications like Cursor, GitHub Copilot. What we are interested in here is that a firm essentially purchases LLM inference through APIs. So firms, they make a request and they get the response, and this is called inference. So we are only going to look at this market. So this is a really large market. This is the primary way firms use LLMs. So that's why it is important. And it has really important like features such as like pricing, different use cases, and so on. And I think an important aspect of this is the pricing is per token. We have linear prices here. So this is very different than the subscription prices that we have in like chatbot market. So this is the inference market where price is linear and firms purchase this inference through the API calls. This is how you can think about the structure of this market. Um, they're essentially like the four layers. The first layer is the model creators. These are the labs that create the model. They train the model and they develop this model. On the inference side, the inference providers take the model and they provide the inference service. They take the model weights, and when you run a query, they run the model. Then we have the aggregator, which is open router, which is going to be important for our paper. The aggregator is it provides a uniform API that can send the request all of different inference providers. So these inference providers, they host the GPUs. When you send the request to them, they run the request through their GPUs. Whereas the open router is just an aggregator in the middle. They don't have their own GPUs. They route the request to the preferred inference provider. And finally, on the application side, there are apps that use these products. So these could be different coding apps, these could be different applications, or these could be different internal firm use. So this is how you should think about the structure of the market. And as you might have noticed, some arrows are bold and thicker than others. This is because these are vertically integrated. So what does this mean? OpenAI, for example, they develop the model and they provide their own inference service, and they also have a product called Codex. Whereas Anthropic, they develop their own models. They provide the inference in their own platform, but they also have a contractual relationship with Google Cloud. So Google Cloud can also serve Anthropic models. Beyond this, we also have open source models. DeepSeek is an example of open source model, and DeepSeek, essentially like any inference provider can download the weights of DeepSeek because it's open source and they can serve the models. So this is how you should think about the market. So we are going to analyze the inference layer, like what models are available in the inference layer, what are the prices of those what are the price of those models, what application, which inference providers have like the higher market share, and so on. And the way we will do this is through Open Router. So the nice thing about Open Router is that it has up to 600 models and close to 100 different providers. So from a single platform, we are able to see the prices of like 600 models, prices of 100 different providers. We also see the usage of their customers. So this is the main advantage of this data. We don't need to collect data inference provider by provider or model by model. This is impossible because these are all like important company secrets. But Open Router, by providing this a routing service, we are able to observe the data set. Okay, I just gave you a summary of this, so I'll skip this slide. Yeah, exactly. The open router is where our data is coming from. We observe tokens by model, date, and application category. So for on a given date, for every application category, like like coding or like marketing, we observe what is the number of tokens processed by a model. So you can essentially observe market shares of different models by data and application category. We also observe prices. For every model provider, we observe prices. We also have some provider characteristics like latency, throughput, and context window. So to the extent that customers care about latency and throughput, so these also will be an important characteristics of the provider. So this is the data that we have. The second data set comes from Azure AI Foundry. Azure is also, it's similar, it's an inference provider. It provides access to close to 100 models, and most of them are OpenAI models, and some of them are open source models. again, similar to OpenRouter, uh, like Azure hosts like these 100 different models, and firms can make a request to each of these models. And in this data set, differently from OpenRouter, we observe market shares at the firm level. So for each firm, for each day, we observe which model each firm chooses from which model, and like the version of the model. Okay, so the difference between this and this is Azure hosts their own GPUs and it's an inference provider. It provides the inference, whereas OpenRouter is they don't have any GPUs. They just route the request to the preferred provider. Okay, so this is how you should think about the market. And just in terms of like how firms use OpenRouter, typically what firms do is firm says, I want to use this model from this provider, and OpenRouter just routes this request to that provider. And sometimes the firm says, I'm going to let you choose the provider because like I just want the lowest price provider. So whichever the provider that is, just send my request. I don't care a specific provider that I use. Okay, so this is the structure of the paper. So let me start with the supply side. On the supply side, what we observe is a rapid growth in models and creators. On the left-hand side, we have the number of models over time, separately by closed source and open source. As you can see, currently there are close to like 100 different models, and there is an explosion of models over time, even just in a couple of years. If you just take even like the early 2024, 2 years ago, we have only 50 models, and now today we have 600 models. Another important point is the explosion of open source models. Initially, we didn't have an open source model, it was only closed source, but then open source model at some point caught up and even exceed the number of closed source models available. So the open source models, they play an important role in this ecosystem. On the right-hand side, we have the number of creators. So these are the model creators, like how many different model creators that we observe in the data that create these models. Here, you can see that we have 10 closed source model creators right now, and this has mostly stabilized over the last year, whereas there has been an increase in number of open source creators over time. And this makes sense because the open source creators, what they can do is they can take another open source model. For example, you can take a DeepSeek model, you can use distillation to create another open source model, or you can create a vertical model, you can create a specific a model. This is specifically designed for a task, and that's why we see the number of open source models increasing. But the point here is there has been an explosion of both the number of models and creators over the last 2 years. This is the number of inference providers. So again, like these are the firms that take the model weights and they serve the inference. When you run a query, they serve that inference. They are separate from the model creators because you can be both a model creator or inference provider, or you can only be a model creator, or you can only be an inference provider. So here we have seen a large number an increase in the number of inference providers as well. And most of these are actually coming from open source models. Why is that? Because everyone can just download the weights of open source models. And if you get a few GPUs, you can essentially run the inference service. So that's why we have seen this huge increase over the last year. So this data is available only over the last year. These are like primarily the labs or the cloud computing firms that serve these models, and we have seen the entry of neo clouds where they enter to serve open source models. This should give you a sense of the competition between providers. here what you see is how many providers offer the same model, the distribution of the number, how many providers offer the same model. So for example, this means that around 200, 250 models are provided only one provider. Around like 70 models are provided by two providers and so on. And you also see this separate for closed and open source. And as you can see, most closed source models are provided one or two providers and up to five. And the reason is that closed source models, they either provide the model themselves or they have a contractual agreement with another provider to sell that model. For example, like Anthropic, they have a contractual agreement with both like Amazon, Google, and Azure, Microsoft Azure, to sell their models on their platform. This limits the number of providers that serve the open closed source models. Whereas we have some models, like maybe like 15 or 20 models, that is provided by more than 10 different providers. And these are all open source models. Why? Because any provider can download these open source models and serve the inference. So I think an important point here is that the competition to serve the open source model is very intense because these providers literally serve this exact same model. The model is the same, and they only compete on like the prices, latency, throughput, and other inference characteristics. Whereas the cloud source models, they compete by model. So an important source of differentiation for them is the model, the capability of model. A copy of models. So in the sense, the market is quite segmented. Open source models, there's an intense competition, many providers offering the same model, whereas the closed source model is only a handful of providers offering the same model. Another interesting point is the differentiation among inference providers. As I told you, these open source inference providers, they pretty much serve the same model. Like they serve the DeepSeek model, they serve the Cloud model, and so on. So their differentiation has to come from somewhere else. What you are seeing here is the ratio, the provider latency relative to minimum latency for the same model. So for example, if there are three providers offering the DeepSeek model, if one has latency of 2 and the other is latency of 1, so the provider that has latency of 2, their latency relative to the minimum latency for model will be essentially 2. So this just shows how much differentiation are there between providers in terms of latency, throughput, and the context window. And the plots actually show a significant differentiation, right? If you look at this latency, around like 15% of the provider model pairs, their latency is 5 times higher than the provider that offers the same model but has the minimum latency. So there is a quite bit of differentiation, and we also see the same thing in throughput, and to some extent in context window. So this suggests that even though there's an intense competition between these providers because they offer the same model, they differentiate themselves through these different characteristics. Okay, now let's move to the models. When we look at the models, what we see is that models are getting more intelligent over time. Here you see the intelligence, and the intelligence is defined by the artificial analysis intelligence index. You see the intelligence of the best model over time. As you can see, there has been an increase in the intelligence over time, and as also the jumps has become smaller over time, and we see more model creators. It was primarily OpenAI early on. Now we see like sometimes DeepSeek, sometimes OpenAI, sometimes like Gemini. There's just an increase in the model capabilities. Um, this was the best model. When you look at the distribution of new models released over distribution of the capabilities of new models over time, you see that the whole distribution actually moves up. So what you see here is the distribution of intelligence index of the models that had been released 6 months before the date. So for example, if you are looking at this point is going to reflect the models that were released 6 months before the date. A couple of interesting points here. The first one is the median capability is increasing, but also the dispersion become more dispersed, right? Even today, when we look at the newly released models, there are some models whose capability is actually pretty low, and we have some models that are at the frontier. This suggests that it is not like there is the new models are always at the frontier. There is only competition at the frontier. There is actually competition at every part of the distribution. Even though the model capabilities have increased over time, there are still new model launches whose capability is as good as the best model like 2 years ago. So this is actually important when we get to the horizontal and vertical differentiation. This will make more sense. This is not there is a competition at the top. There is competition at every segment of the market. And these are the prices over time. So actually, let me show you this one, and then I'll go back to this. Here, what you see is that for every intelligence bin, you observe the price of the minimum, the price of the lowest price model over time. So for example, if I just zoom into this one, this is the first model GPT-4. And this is the intelligence between 20 and 30. This is the intelligence between 0 to 10. And over time, we look at the price of the lowest price model in this intelligence bin. And as you can see, the price, it goes down from $30 to actually 3 cents. So this is a 10x price decline. And you see not you don't see only not only this like GPT-4 or like 20 to 30 intelligence. In every single intelligence spin, there is a huge decline in prices. This just reflects the decline in prices overall. So overall, we have seen in the last like 3 years, 1000x price decline. But despite this price decline, when we look at the actual prices firms pay, so this is the average prices firms pay, distribution of prices firms pay, we see that it is mostly flat because firms, what they do is they upgrade to the new model as the new models are released. So let me skip this one for the sake of time. Okay, so this is this is my favorite plot in this paper. So let me tell you what this is. This shows the prompt price on the y-axis. This is the log scale. And on the x-axis, it is the intelligence index. So first of all, you see the relationship between price and intelligence index, and this is more or less linear. We suggest that the relationship between price and intelligence index is log linear. So every increment of increasing the intelligence index leads to an order of magnitude higher price. So the first observation is price and intelligence is log linear. Second, you see the open and closed source models. The blue ones are closed source and the yellow ones are open source. As you can see, the yellow ones are almost always below the fitted line, meaning that for any intelligence level, the open source models are cheaper than their closed source counterparts. And when you run a regression, you find that they're actually 90% cheaper at the same intelligence level. But if you look at the size of these dots, which reflect the market share of these models, what we see is closed source models have a higher market share than the open source models given an intelligence level. So this suggests a puzzle. We have similarly capable open or closed source models. Open source models are 90% cheaper, but they only have 30% market share. So why is that? There's a couple of explanations. The first one is maybe the intelligence index is not good enough, right? Maybe it doesn't really capture the differences between models. So even though, let's say like this model and this model, they have the same intelligence index, uh, their actual capabilities are very different in a way that is not captured by this intelligence index. The second reason is there could be other dimensions other than the intelligence firms care about, right? So closed source models often they come with some customer service, they come with some security guarantees, and maybe these some other product characteristics that is not captured by intelligence index, but uh, people care about. And finally, this could be just some behavioral uh, bias, right? Maybe these models are truly identical, they give the same performance, but the consumer's perception of open source model is different. They see open source model inferior relative to closed source models, even though they are actually not. I think this is one of the like most important questions in this market. Uh, is open source models are inferior to closed source models, even given the intelligence index? And if so, how can we capture that? Um, okay, so let me skip this one. So related to pricing, an important point is that open source prices are a lot more volatile and fluctuate a lot more than the closed source ones. Here, what you see is the probability of price change, weighted and unweighted, uh, in a given week. So, for example, when we do token weighted, uh, an open source model has 10% chance of changing their price on a given week, whereas this is only 1% for closed source models. This is also quite like interesting. I think this can come from the fact that there is a lot more competition within the open source space than the closed source, as I explained earlier. But I think it's kind of a puzzle also that the closed source providers, they don't change their prices so often. And like even though they release new models, they keep the prices of their old models the same. There's there's some couple of different explanations, like they want to retire those models or they don't want people to use those models, or since those are early training runs, they are actually costlier to serve than the newer models, even though newer models are better. I don't know the exact answer, but I think this is an important aspect to think about in this industry. Um, okay, so this is about the price variation of um, the price variation of the same model across providers. Okay, so we have the exact same model offered by different providers, and we look at the price variation through coefficient of variation. So essentially, each observation is a model here, and it reflects the coefficient of variation of prices across providers. As you can see, the price variation is huge for open source models. There are some open source models where the coefficient of variation of prices is 1. So the standard deviation is as large as mean. Whereas if you look at the closed source models, there is almost no price variation. Like we have most of the mess at 0. This means there is no price variation for these models. And again, this comes from the following observation. The closed source models, when OpenAI, Anthropic, they sign an agreement with Azure or like AWS to serve their models, they actually impose their prices. Like they say, you are going to offer this model at the same price that I'm offering. So they have the ability to dictate their prices. Whereas this is not true for closed source models because there's an open market, everyone can download the weights and then set their prices. That's why we see a lot more price variation in open source models than closed source models. Okay, so let's move to demand side a little bit. So we finished the supply side and the pricing side. Let's move to the demand side. Here, what you see is the market share of model creators over time. So we have like the major labs, XAI, Google, Anthropic, OpenAI, and so on. An interesting observation here is there is quite a bit of turnover in among the model creators in terms of their market share. For example, we can look at like DeepSeek here. So DeepSeek became quite popular like mid 2025 when they released their reasoning model, but then over time their market share actually went down. XAI, what they did is they released their coding model and they price at a really, really low price, and they gain a lot of market share from, for example, like Google and Anthropic. Anthropic used to be a lot more popular in the beginning of the year, and their market share went down. This is mostly due to like the XAI offering a really competitive price. But the point of this slide is that there is dynamism in this industry. It is not that we have OpenAI, Anthropic, they have like 50-50 market share, and that is the industry. Here you see the market share of open and closed source models. I mentioned this briefly earlier. Overall, open source models have around like 30% market share, whereas closed source, they maintain 60-70% market share. This is the DeepSeek moment. We have seen increase in the market share of open source models, but then they went down over time. Now we look at the market shares in terms of the models, not the creators, but the models. Here, the dynamism is even bigger, right? Like if you look at this color red, it is the others, and they have 100% market share, just like last year around this time, which means that today, if you look at the top 10 model today or like December, none of them were even available a year ago. There has been huge turnover in this market in terms of the model. There are many new models are being released, and these models gain momentum and market share quickly after they are released. And this is just like the pattern in this industry. This is one way to get to the concentration. So here you see the market share of the top provider, second top, third top, and so on at any point in time. So I pick a time and I look at the market share of the top provider, second top provider, and so on. As you can see, the market is not hugely concentrated. Even the creators that are between 6 to 10, they maintain around like 10 to 15% market share. And this is mostly stable. This is again suggesting that the market is relatively competitive. There are many creators that are competing for the customers, and we don't see a clear dominance of one model creator over time. So the creators, they swap places, right? Like sometimes like DeepSeek becomes the top, and sometimes like XAI becomes the top, and so on. But the market share of the top creator is pretty stable. Okay, this is my another favorite plot, or maybe like second favorite plot of this paper. Here, what you see is the top model, in each category over time. So the color indicates the creator of the model. So for example, like blue is Anthropic, yellow is other, green is DeepSeek, and so on. Whereas you see the name of the model right above the bar. What do you see here? First of all, you don't see a single color. You see many different colors, suggesting that not a single model dominates all categories. Right? This suggests that there is some potential vertical, horizontal differentiation in this market. It is not that like some models, some model creators have higher market share than in some categories than other creators. Another important thing to observe is that in almost every category, the top model is changing over time. And so, for example, if you look at the legal category, we go from like Gemini plus 1.5 to 2, 2.5, and so on. So each category, they upgrade their models if the models are released. But these upgrades are happening at different times. So, for example, like finance, health, legal, they moved to Gemini 2.5 Flash, whereas academia is still using Gemini 2.5, 2.0. And like another example is if you look at programming, so they immediately adopt the most recent technology, for example, Cloud for here, whereas like the technology category they adapted a bit later. So this suggests that there is quite a bit of horizontal differentiation. Models have different comparative advantage in different categories, and categories have different intelligence needs. So not all categories need to use the top model. And this is one way of seeing this. What I'm showing you is the average intelligence index of all tokens in that category. Programming is at the top, so programming is demanding the highest intelligence. Then we have science, technology, and at the bottom it is translation. Why? Because translation is a simpler task than programming, so they don't need to use the best model over time because best model are expensive. So for translation, paying the premium for the top model, the best model, is not worth it. So we have see this different intelligence needs. So this is also indicative of vertical differentiation, right? Because not everyone needs the best model. So we have a spectrum of models by their intelligence, by their capability, and different segments use different segments of the intelligence model. And this is also reflected in their prices. The price they pay is very different. It really depends on how much intelligence they need. This is another way of showing this, actually. Here, what you see is the highest intelligence model, the lowest intelligence model, and the distribution of the intelligence over time. So this is the intelligence of the median token. This is the intelligence of the 90th percentile token, and so on. Again, as I mentioned before, it's not that like everyone the distribution is concentrated here. There are some use cases that need really high intelligence, and there are some use cases that they don't require this intelligence, high intelligence, and this is reflected in the distribution. So here we look at the market concentration in a more direct way. We just calculate the HHI in each category. And as you can see, even within a category, the concentration is like relatively low. For example, only in a translation, the concentration is HHI is such that it is equivalent to 2 equal firms. Most categories are between 2 to 3 firms, and some categories are between 3 to 4 firms. So now I'm going to analyze the model entry a little bit. I'm going to look at whether a model entry leads to substitution versus a model entry leads to market expansion. This is a really not like easy and like I think natural thing to do here because we have seen so many model entry in this market. And here you see the total number of tokens over time, and vertically you see the entry of these models. I think there is some evidence of market share, for example, especially after Grok enters, like we see an increase in the number of tokens. But overall, also like these are not that large, so it's not that a model entry generates a huge demand. And you also see a different pattern. So, for example, this is the entry of Cloud 3.7. When it enters, there is nearly 1-for-1 substitution from Cloud 3.5, right? So what they do is when this model is launched, people who use Cloud 3.5 before they move to 3.7. But for example, when we look at Gemini, we actually see that it generates some market expansion. It's not that they steal market share from some other models, and we also see the same thing for Grok. So just like to summarize, we see some heterogeneous substitution patterns, like some models generate market expansion in open router, some models generate substitution, and we also find quite a bit of horizontal differentiation, both across creators and also vertical differentiation across creator families. And the implication is that models are differentiated in ways that are not fully captured by benchmarks. So let me move to multi-homing, the last analysis. Here, what you see is that the share of firms by the number of models they use. So, for example, 60% of the firms use one model, 20% of the models like use two models, and so on. So there is some multi-homing, but not that much. So still, most firms use a single model. But even when you look at the multi-homers, we actually see that most of them allocate more than 90% of their usage to one model. So this suggests that even if I use multiple models, majority of my usage is in one model, and I also have similar amount of usage in a different model. This is consistent with the experimentation. It is possible that there is one model that I use for all of my production, but every now and then I experiment with a new model, and that will generate this pattern. Okay, just to conclude, we have seen rapid supply side growth in this market and dramatic price declines. The market is very dynamic. It is somewhat concentrated depending on the category and whether you look at the model and the creator level. Some model entry generate market expansion, some model entry generate within family substitutions, and there is some multi-homing. Multi-homing seems consistent with experimentation because even if firms multi-home, most of their usage is only one. Thank you so much.
Great. Thank you so much for the great talk, Mert. I think it really gives us some insights about the market structure of LLM. So before I open the floor to the general audience for Q&A, I myself have a question. So I think our paper shows that users they don't simply like try to use one simple best model, right? So there's a big story about a differentiation there. So you said a little bit about it, but can you offer more insights into how exactly should we thinking about what buyers are sort of getting besides these capabilities? So is it about the brand? Is it about the ecosystem? And what does that mean for
Yeah.
the market structure in the long run?
I think like we can think about like three forms of clear differentiation here. One is clearly vertical, because like some models are better, and we see that some categories require more intelligence. So there's a clear vertical differentiation that serve the needs to different categories at different needs. The other one is some form of horizontal differentiation, right? Even if you conditional on the same capability. For example, Anthropic is very popular among programmers. And for example, like Gemini is very popular among like the marketing use cases. So there, I think this could be habit formation, or like this could be differences in the capabilities on particular use cases. But even if you condition on the same intelligence, I think some models are better on different use cases than others, and this is what is reflected in the data. And the third one is the open and the closed source. There is a clear differentiation there because, as I said, we see 30% market share of open source models, despite the fact that they are 90% more expensive. And this is 90% less expensive. So this is a differentiation that our benchmarks don't capture, but this is clear in the data. So I think in terms of the implications, um, on the I think that vertical differentiation will continue for sure because these models are expensive and not all use cases need the best model. So like there will be vertical differentiation for sure. I think horizontal differentiation will likely increase because there is more room for horizontal differentiation going forward, especially if you collect data from specific use cases. For example, like Cursor just released their composer model and they use their like own data from developers that they collected. So I think as these applications they collect more and more data, I think there will be more room for vertical horizontal differentiation. And the open and closed source, it's a really open question. I think that is like the most unknown and most, I think, hard to predict going forward. So that I'm not sure like what insights we can have for the future.
Got it. And just a very quick clarification before moving to the audience, because I see a couple of hands up. What exactly is intelligence index?
So we use an intelligence index from Artificial Analysis. Artificial Analysis is a benchmarking company. So they do category by category benchmarking, like the coding, math, and so on. So we use their uh, overall index that is aggregated across different categories. But these indices are extremely correlated, like 90-95% correlated. Actually, it doesn't matter which one that you look at, but this is what we use
Got
in
it.
the paper
Got it.
throughout.
Okay. Thanks. So I see the Xavier's hands is up. And we also have a couple of questions from the comments. So why don't you just unmute yourself and ask your question, please?
Thank you. Thank you for it's a very informative talk and paper. I would like to ask how representative is your analysis of the market, no, of the LLM inference via APIs for firms? I say that because I've been a little bit surprised by the fact that OpenAI looks underrepresented. Well, maybe it's like this,
Yeah.
but it definitely looks underrepresented in terms of both the models, the shares, the leading models, etc. No, can you guess? No, what in a sense how representative is your analysis with Open Router and Azure? Thank you.
Yes. No, that's a really important point I should clarify. Thanks for the question. I think on the supply side, it is very representative because Open Router provides like every single commercially available model. Like it is somewhat popular. Like even if the model has like 0.01% like the market share, they still provide it. On the supply side, we actually like of course, if you go to Hugging Face, there is 2 million models. But those are not the models that firms are going to use. Those are just like some open source models, people experiment and so on. In this sense, on the supply side, we capture all commercially relevant models. So this applies to like number of models, number of creators, inference providers, and like the pricing and so on. But on the demand side, of course, this is not representative of the entire industry. Open Router, we don't know the Open Router's market share because like these numbers are very secretive, but it is definitely less than 10%. And I think the usage is somewhat concentrated among young tech firms and like developers. So in that sense, I wouldn't argue that like the demand side is extremely representative. So like I wouldn't take these market shares as the market shares of the entire industry. But I think we can still learn from the change or like the relative change over time, because I see no reason why the change of demand over time will be significantly different than change of demand over time in open router is significantly different than the change of demand over time in the entire industry. And that's another reason why we use data from both Azure and Open Router. I haven't shown these to you, but we confirm most of the patterns in the paper, both in Open Router and Azure data. So this gives us a bit more confidence that this is representative of the industry, but it is impossible to know because the data is not available.
And I see hand up from Chen Long. Long, you want to unmute yourself and ask the question since your hands up? Okay, and we also have a question from the audience. It's a very long one, so do you want to unmute yourself and ask that question? Yeah, just feel free to unmute yourself and ask a question.
So shall I proceed?
Yeah.
Yeah. So hi. I'm PhD student from HKU and currently do this trying to export data on the open router. And one thing I worried at is that I checked the app usage on the open router and noticed that most of the API goes to the open cloud and some part of
Right.
go to the cloud code.
Yes.
And
Can you see me? Yes. Can you see me?
Yes. Yes.
Yeah.
Hello.
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 Yes.
Can you
Yes. We
hear
can hear
me?
you, Long. Yes. Go ahead, Jiazi. Keep asking your question.
Yeah. Probably don't have some connection issues. And so I'm worrying that the supply may not, I mean, the supply market, the supply side of the market, we can definitely see it. But the demand side could be driven by the reason that some of the model are really cheap. And so that people play more with the open cloud or like cloud code to produce something that are not costly to them. So the demand image may change over time and due to some kind of supply structure and may not be representative to the whole world because those people are those players that use open cloud. Well, in the real world, I don't think
Yes.
there's many people use that.
No, that's a good point. I guess like one clarification, our data ends in December in this paper, so this before on cloud. And I also agree that like open source is probably more representative in our data than the general usage. But even if you take this 30% market share of open source as like true market share, which is like an overestimate, I think it's still like it makes paper more conservative. So I think these are all like valid points. So that's why we don't wanna like we never say the market share, like the best model is like the Anthropic is like the model with the highest market share and so on. So we avoid making those claims. Our goal is really okay. So this is the best available demand data. There is no other demand data available.
Mhm.
What can we learn? What can we learn from this? I completely agree with this, Kerry.
Thank you.
Yeah. And Mert, while we're waiting for Long to fix his speaker issue, I have another
Yes.
question. So recently, oh,
Yes.
okay, Long, so you're good. Go ahead.
Yes. Well, firstly, thank you, Mert, for presenting such a intriguing, interesting, super interesting paper. I think the time is short. I think what's most impressive for you is evidence is that there's such the talk you present the dynamic of really it's more as supply and demand. But I think what's really impressive here is that because people really just look at the scoring of different models, they look similar. But actually, what here you present is a very dynamic picture. I think we can tell that each the LLMs at a different stage and or different models, they are different animals in the sense that they have unique quality and price combination, cost combination, such that on the demand side, they will stick to those. So I think that's the most impressive to me. And also there's a lot of difference, and also this difference persists, such as the open source versus the closed-end models. But I guess my question, or as some previous listeners have suggested, I think the two key questions here is really I don't know why, and I don't know this will change. You would think that a later model or a better model. Sometimes we talk about winner takes all. So you'd think the later ones will cover the previous ones and it will cover more space, but that's not the case. It seems that every stage and every the different models are different animals. I don't know this will change, and nor do I know why. So I think when reading this super interesting paper, I feel like this very good document of the interesting patterns, but it does not provide enough reason, nor does it suggest that will this continue. Could you elaborate a little bit on
Yeah.
this?
Yeah, I think no, this is a good point. It is like it's impossible to predict the future when it comes to LLMs. I think if you do that, then like I think one can become a billionaire pretty easily. Um, so like the one comment is this is maybe not that surprising because in early phase of every new technology and industry, it is like you see this dynamism, right? Like we had many search engines before Google took over. We had like many browsers before like Internet Explorer took over the industry. Like when even if you go back to cars, right? There were hundreds of car manufacturers, and most of them went out of business. In this sense, this is not that different from the early phases of previous technologies. What is different though here is the dynamism. It's like a lot
Well,
faster, quicker than the previous technologies. So in this sense, I think the natural evolution of these like new technologies is there is more competition, more dynamism, more entry and exit early on, and then it stabilizes at some point. I think that's gonna happen like to some extent. Also, it is maybe happening with closed source models already. Um, so I think my sense is the trend of the industries like it will be like maybe more stable, like less dynamic, maybe a higher concentration and so on. But it's like hard to know, impossible to know like to what extent that will happen and how quickly that will happen. So yeah, I guess we can just look at the data we have, document what we observe, and try to interpret our finding to make predictions about the future. But that's a really difficult thing to do.
yeah, but so you see you have provided one interpretation based on your understanding of history. So the key question is what is the essence of this AI? What is AI about? It seems to me that these different models represent different stage of AI, and they're so different. So is that it, or will this persist? And you provide one interpretation. You said, well, maybe if we look at earlier technologies similar like this, that's one interpretation, maybe others. But that interpretation actually means something. It means that it won't last. It's not a
Yeah.
stable dynamic. So
Yeah.
I would really want to like you to discuss a bit more or get some data, some reference on this, so that
Yeah.
I think it will go much further
Yeah.
to
Yeah.
enrich the
Yeah.
paper.
Yeah, I think no. So like one way to do this is like if we had user level data, we can measure these differentiation is a lot better. We can try to measure the trend a lot better. I think these are the questions I'm working on currently, like different data sets, different settings. But I think with this data set, like I certainly don't want to overclaim. So this is probably the best that we can tell.
Great. I think we're right on time. So I'm gonna have to end the Q&A there. So Mert, thank you very much for taking the time to share your wonderful work with us. And I also want to thank the audience, who tuned in, listened to the talk, and for your excellent discussion here. So have a great rest of your day, everyone. Thanks for joining us.
Yeah, thank you.
Bye.
Thank you.